Hello, Assalamu alaikum. Are you all able to hear me? And is the screen visible?
Yes, miss.
Okay. We're going to today start off with the contact process. Does anyone have any questions from yesterday's session? Yes, Zoya.
Miss, we did not discuss the effect of concentration on equilibrium.
The effect of concentration on the equilibrium. Concentration basically is going to it is going to increase the. It means that increasing the number of molecules in a certain given volume. Okay. Keeping in mind that the volume does not change. Okay. Generally, concentration basically acts like just like the pressure. Okay. So when you're increasing the concentration of a particular reactant, yeah, now basically the questions that they usually come up in exam, you have to look into that. Yes, when we're talking about so for instance, if I say that there are two different reactants and they're producing a product and C and D is produced as a result. And this is an already established equilibrium. This has reached or its equilibrium. Okay. For instance, if I increase the concentration of the reactants, okay, this means that I'm increasing the number of molecules of the reactants. Okay. When the number of molecules of the reactants, they on the left hand side, there is going to increase. It is going to, as a result, they're going to collide with each other more frequently, thereby increasing the product yield. Okay. So the questions which come up in exam, they are there's an interplay of different factors which is going to affect the product yield, which is going to affect the rate of the reaction, and would also affect the position of the equilibrium. Okay. So increasing concentration basically means that more and more product will be formed. The rate of reaction is going to increase. So we can say concentration and the rate of reaction is basically directly proportional to each other. All right. And increasing the concentration of the reactant would also, as a result, mean that the equilibrium is going to be shifted towards the right hand side, right? More and more product is formed, right? This means that greater concentration would increase the rate of reaction, hence thereby increasing the product yield. And this means that the equilibrium position has been shifted towards the right. Is this point clear or what?
Yes, miss.
Then, when similarly, when I say supposedly that you decrease the concentration, this means that the rate of reaction is decreased. There are now less number of molecules. As a result, the product yield is also going to decrease. Okay, which means that the equilibrium is going to shift towards the right hand side. Okay, why? Because decreasing the concentration of the reactants hence means that the already established equilibrium now has less number of reactant molecules. Okay, there are now less number of reactant molecules. The Lee-Chateliers, according to the Lee-Chateliers principle, it is going to oppose to that change to bring about greater amount or the greater amount of the reactant molecules. Thereby, the backward reaction is going to increase, which means that the equilibrium position is shifted towards the left hand side to, as a result, thereby increase the concentration of the reactant and restoring the equilibrium once more. Okay. Other than this, you also have to look into the concentrations of the product. Supposedly, I say that the concentration of the product is increased. There is an already established equilibrium. There are reactions and products both within the reaction mixture, but then I increase the product concentration um, within the reaction mixture. Okay. So what is going to happen if there is already when I'm going to increase the concentration of the product, it should move to which side, the left hand side or the right hand side? The shifting of the equilibrium takes place towards the left or towards the right. When there is
To increase the concentration of the products.
when we increase the concentration of the products.
So it shifts to the left.
Yes, it is going to shift towards the left, all right, which means that it is going to oppose to the change, all right. We always have to look into the shifting of the equilibrium lies always that where to oppose to the change of the external factor or the external condition. Similarly, if we decrease the concentration of the product, this means that we need to increase the concentration of the products once again. So the equilibrium will shift towards the right hand side, hence favoring greater product yield. Okay. So the rate of the forward reaction has to increase. So all of these things, when they're asked in a particular question, they will ask you in a complex interplay. Okay. They're going to give you a particular situation and they will say that what happens to the product's yield. And they're going to ask you what happens to the position of the equilibrium. Sometimes they're going to ask you in terms of particle equilibrium theory to explain the rate of the reaction, whether the rate of the forward reaction increases or whether the rate of backward reaction increases. Okay. And catalyst, remember, catalyst, they increase the rate of reaction in the same amount for forward reaction and for backward reaction. As a result, we say that the the position of the equilibrium is not shifted to one particular place. Okay, neither to the right nor to the left. Okay. So, for instance, if I ask you one question here, okay, let me go the equation. For example, I say that you have iodine fluoride. Okay. And this iodine fluoride is basically dark brown in color. And then it reacts with chlorine and establishes an equilibrium. So reversible sign for equilibrium, since they are reversible reactions, and iodine trifluoride is one. Okay. When this particular product is formed, the color of this product is yellow. What do you think if the concentration of the iodine trifluoride is increased? Where is the equilibrium going to be affected? If the concentration of the iodine trifluoride increases, where is the shifting of the equilibrium takes place? Yes, very good. It is going to shift towards the left, all right, to oppose to the change, to minimize that change. As a result, more iodine monochloride or ICl or the reactants they will be formed. So, what observations are you going to notice when you look into that the reaction or the established equilibrium shifts towards the left? This means more of the reactants they are formed. This means that there should be some kind of an observation. It's more dark brown color. Yes. So we can say that the color is going to get much darker. Next, for instance, if I say that this chlorine is removed, some of the chlorine is removed from the equilibrium mixture. Okay, how is this going to affect the equilibrium, the position of the equilibrium?
Could you please repeat the question?
If I remove the some of the chlorine from the equilibrium, from the reactant mixture, how does this affect the equilibrium position? Yeah, you can say concentration of the reactants is decreasing. There are now less molecules of chlorine on the reactant side. Yes, again, it is going to flip towards the left. So your observation is going to be that more dark brown color will be seen or observed. Okay. Now, for instance, if I say that I am increasing the concentration of iodine monochloride, that is ICL. Is this point clear so far? How the equilibrium position is shifted towards the left, and why do we observe the greater dark brown color or darker brown color? Yes. Any questions? Okay. And for instance, if I say that I'm adding in furthermore more and more iodine monochloride, okay, so I more ICL is added to the reaction mixture. How does this affects the equilibrium position?
The concentration of the reactants will increase, ma'am, and
Yeah.
so the equilibrium will shift to the right.
Very good. So what will be your observations?
That the reaction mixture will turn yellowish or
Yeah.
more lighter in color.
Yeah, more paler you can say, or it is going to turn yellowish. So so this is how you basically identify the changes in the concentration, and you can also say that the product yield is also going to increase. Okay, or the concentration of the product tends to increase. Okay, so let's move on to the contact process. Is this point all clear so far regarding the shifting of the equilibrium? How you're going to identify the product yield, the rate of reactions, and everything? Yes, I am.
Ma'am, can you just quickly explain? Actually, I arrived late here. I'm sorry. So, like, in when we decrease the concentration of chlorine, how will the equilibrium shift towards the left? Can you just explain this part?
Decreasing the concent or removing decreasing the concentration of the chlorine or removing some of the chlorine from the reaction mixture basically decreases the overall reactant concentration, right? And according to the Lee-Chatelier's principle, it has to oppose to the external change, whatever external change you have brought about to the already established equilibrium. It has to oppose it, right? So then the already established equilibrium would want to increase the concentration of chlorine once again, which is why the equilibrium position shifts towards the left.
Okay, ma'am.
Similarly, if you look into the Haber's process, okay, the after ammonia is manufactured, ammonia is taken out from the after being manufactured, it is taken out from the reaction mixture or the reaction vessel. So removing the ammonia from the reaction vessel basically allows the reaction to proceed in the forward direction, thereby again increasing the product yield. Okay. So it is important, and this is the significance that which is carried out through this particular process of removing ammonia from the reaction mixture and then liquefying it. Okay, so it is important that we remove ammonia from the reaction mixture so that more and more product yield can be achieved. Okay,
Okay, ma'am. Right.
let's look into the contact process now. So contact process is basically the sulfuric acid, or you can say that concentrated sulfuric acid. It is manufactured by the process that is your contact process. However, the particular reaction which takes place, which is the equilibrium, where equilibrium is established, is when sulfur dioxide is going to react with oxygen to produce sulfur dioxide. Okay. Not balancing the equation here. Complicates. This is balancing. So the contact process is basically the reversible equilibrium is established when sulfur dioxide reacts with oxygen to produce sulfur dioxide. Okay. The concentrated sulfuric acid, which is produced as a result, is actually a very, very powerful oxidizing agent. Okay. And this means that in any particular reaction with the other counterpart or the other species or the other substance is a good reducing agent, it is going to oxidize the other substance and itself it is going to get reduced. We are going to come to this further explanation of what are oxidizing and reducing agents when we are going to look into redox reactions. Whereas however, just understand this point that concentrated sulfuric acid is basically a very powerful oxidizing agent. Okay, and it has the ability to absorb moisture. Okay, so it is also used as a drying agent as well. Okay. Other uses of concentrated sulfuric acid is that they are also used in fertilizers, in soaps, in detergents, okay, and also in some in car batteries, okay. The first process that basically takes place through this contact process is the first step that occurs is where sulfur is burnt, or you can say it is roasted in excess of oxygen to produce sulfur dioxide, okay. So first of sulfur dioxide is produced when sulfur is going to react with oxygen or it is burned in excess of oxygen to produce a sulfur dioxide. You can also say that oxidation reaction basically takes place here. So other than this process, any metal sulfide, okay, any metal sulfide, if it also reacts with oxygen, then also metal oxide and sulfur dioxide is produced. So either simply sulfur is going to be roasted in air or it will be burnt in air. It is going to undergo the process of oxidation to produce sulfur dioxide, or any metal sulfide can also react with oxygen to produce sulfur dioxide, and metal will be produced on the metal oxide will be produced on the other hand. Okay. Metal oxide is produced and sulfur dioxide is produced. Okay. So metal and sulfur, both of them they get oxidized here. Okay. The next step is that sulfur dioxide, when it reacts with oxygen, it is going to produce sulfur trioxide, and this particular reaction is a reversible reaction. How do we notice that? When we look into the reversible reaction sign. Okay. The forward reaction here is exothermic in nature, and the backward reaction here is endothermic in nature. Okay. And if you look into this particular reaction, does anyone remember what are the reaction conditions for the Haber process? It is very important to memorize the reaction conditions. Yes, Ryan.
It needs to be at 450 degrees Celsius and atmospheric pressure. Or not, no. It was 550 degrees Celsius and 300 atmospheric pressure.
200 atmospheres.
Oh.
200 atmospheres. What is the catalyst which we use?
Nickel?
No, iron is used as a catalyst. Okay. Iron is used as a catalyst. 450 degrees Celsius is your temperature and pressure remains 200 atmospheres. And 200 atmospheres basically means it is 200,000 kilopascals. Okay. Then if you look into the conditions of for the contact process, the conditions of the contact process are 450 degrees Celsius temperature, 200 2 atmospheres pressure, and vanadium 5 oxide is used as a catalyst. Okay, 450 degrees Celsius temperature, 2 atmospheres pressure, and vanadium 5 oxide acts as a catalyst. Again, if you look into this, both of these catalysts which are used here, they actually involve transition elements or compounds of transition elements. So transition elements, they have a great ability to be used as a catalyst. Okay, they're going to catalyze the whole reaction. As a result, this the rate of reaction basically increases, okay, but does not shifts the position of the equilibrium to any particular side. Once this sulfur trioxide is produced as a result, it undergoes many other further reactions um, to produce the final concentrated sulfuric acid. For instance, the sulfur trioxide is then further absorbed into uh, at least 98% of sulfuric acid, okay, to produce disulfuric acid, which is also called as oleum. Oleum, which is thick, okay, in its consistency. So it is going to be absorbed into H2SO4 to produce H2S2O7, and this is referred to as oleum. Also called disulfuric acid, and this is thick in consistency. All right, you should know these steps, but usually the questions, high frequency questions, they come up from this particular rate of reaction, but you should know all of these concepts. Okay. However, then when this disulfuric acid is produced, then it is added to water. H2S2O7 is then further added to water to produce the concentrated sulfuric acid. Do we have any questions by far? Yes, I am.
Ma'am, in step 3, where did the sulfuric acid come from? Like it was already made before?
Yes, already. Oh, yeah, yes. Yes, exactly.
Ah, oh,
So, so
oh,
that is then and it is only 98% sulfuric acid. So sulfur trioxide is then absorbed into 98% of sulfuric acid to produce this oleum, which is H2S2O7. Yes, Zoya.
okay.
Miss, at the start, you mentioned some important uses of this sulfuric acid. Could you repeat them again?
The uses of sulfuric acid, they are first off, this is a very powerful oxidizing agent, and it is used as a drying agent. It is present in car batteries, and it is used as a detergent, as soaps, fertilizers. Right? Yes, I am.
Miss, I don't really understand like the MS plus O2 becomes MO plus SO2.
Which part?
The MS plus O2 becomes MO plus SO2. I don't really understand that.
You didn't understand the first part. Okay. So basically, in the first reaction here that you're able to look into, this one, there are two ways to produce sulfur dioxide. Okay, there's not just this one particular way, but there are two different ways to produce sulfur dioxide. We want sulfur dioxide so that it can be further oxidized to produce sulfur trioxide. Okay. So the other way to produce sulfur dioxide is other than roasting it in air or burning it in air to form sulfur dioxide. Metal sulfide, MS means metal sulfide. Okay. It is going to undergo oxidation reaction in the presence of oxygen to produce metal oxide and sulfur dioxide. Okay. For instance, this could be iron sulfide. Iron sulfide is going to react with oxygen to produce iron oxide. All right. MO means metal oxide. So this could be iron oxide, which is formed, and then sulfur dioxide is produced. Clear?
Yes, but can it be any metal?
It could be any metal. Okay. And then if you look into this, the reaction conditions that are mentioned, these are all compromised temperatures, compromised pressures, which are basically used. Okay. So now let's look into how the reaction basically
Miss, before you move on, can I ask something?
Yes.
So in step 3, we react the what's that called? The SO3 with H2SO4. But
Sulfur trioxide reacts with H2SO4.
yeah, so why do we react this with this when we get H2SO4 in the end anyway in step 4?
No, sulfur trioxide is basically, it cannot be dissolved in directly, it cannot be dissolved into water, no? So since it cannot be directly dissolved into water, which is why it is first absorbed into concentrated 98% sulfuric acid to form oleum, and that oleum which is formed is then absorbed into water. Okay, then it is dissolved into water. All right.
So we're just doing this to completely eradicate the sulfur trioxide?
Sorry, come again.
I'm saying like we are doing step 3 and step 4 to remove sulfur trioxide completely.
Yes, now obviously after formation of sulfur trioxide, we now want to form concentrated sulfuric acid. No? So if you want concentrated sulfuric acid, we have to go through these steps 3 and 4 to form sulfuric acid as a result. They have to be reacted with some other species or other substances to produce concentrated sulfuric acid. As it cannot be absorbed directly into water, which is why it is first absorbed into 98% sulfuric acid to form oleum. And then when oleum is formed, then oleum is going to react with water to produce concentrated sulfuric acid at the end.
Okay.
The contact process is basically the synthesis of or manufacturing of concentrated sulfuric acid. However, the particular reaction, which is the reversible reaction, is only this production of sulfur trioxide. Okay, so this production of sulfur dioxide, we look at one more thing here. This is the correct equation as well. This is also the correct equation. Okay. So, for instance, I did not write 2SO2 plus O2 to form 2SO3. I just wrote half of oxygen atom, right? Half of oxygen atom, oxygen molecule basically means one oxygen atom is reacting to produce sulfur trioxide. But both of them, they are correct ways of writing it. Okay, so don't get confused. You can write this particular reaction if you're feasible with this one. Okay, so let's look into how basically how this rest of the temperatures and the pressures, they basically impact the reaction. For instance, if I'm going to write, let's write down the equation here. Forward reaction is exo. In both of these processes, the forward reaction is exo. Backward reaction is endo. Okay. Sometimes they're going to mention that a particular reaction is exo or endo. How? They will either write in one particular statement that the forward reaction is exothermic. This means obviously that the backward one is endo. Or they're going to mention that forward reaction is endo. This would mean that the backward reaction is exo. Or otherwise, they are going to mention delta H value if they don't mention it in qualitative way. Okay, if they don't simply write a first statement, they're going to mention the delta H value. So this means that the delta H value for the forward reaction is either negative here. Okay, in this particular case scenario, the delta H value for the forward reaction is negative. Why? Because the forward reaction is exothermic in nature. Okay, so what is going to happen if I increase the temperature to greater than 450? 450 is the compromised temperature. If I increase that temperature to more than 450, supposedly 600 degrees Celsius is used, what is going to happen to the product yield and to the shifting of the equilibrium solution? Yes, so yeah.
The equilibrium shifts to the left towards the reactant side, and the product yield decreases.
Why does it shift towards the left?
Because the left side is endothermic, so it favors endothermic reactions.
Yes, the backward reaction is endothermic. The left side is not endothermic. The backward reaction is endothermic, which is why increasing the temperature basically favors endothermic reaction. Very good. So we are able to identify that increasing temperatures or higher temperatures basically favor the backward reaction, since it is endothermic, which means that higher yield of the reactants will be achieved. Okay, higher yield of the reactants will be achieved, thereby undermining the actual production of the product yield. Okay, and obviously if you're carrying out this process industrially, we want more product yield. Okay, which is why a compromised temperature of 450 degrees Celsius is kept, so that it does not favor endothermic reaction. Yes, Ryan.
I'm just a bit confused. If there are more yield of reactants, won't they react and form more products?
If there are more yield of the reactants, yes, they will form more product.
So why is there like a decrease in the product?
Because you have not changed the concentration. No? Concentration of the product and the reactants within the equilibrium mixture remains the same. We are changing the temperature. Okay. When we increase the temperature, whenever we increase the temperature, it is going to favor wait. It is going to favor the endothermic reaction. And which one is the endothermic reaction?
The backwards reaction?
The backward reaction. So according to the Lee-Chatelier's principle, higher temperature tends to favor endothermic reactions. So if higher temperature is favoring endothermic reactions, this means that which one is the backward one is the endothermic, which is why the equilibrium position shifts towards the left, which means more reactants will be formed. Okay, to restore the equilibrium once again, and thereby decreasing the product yield, or subsequently decreasing the product yield. Are we clear?
Yes, miss.
Okay. Now you tell me, if I am going to decrease the temperature, for instance, I've decreased this temperature to 200 degrees Celsius or 300 degrees Celsius, what is going to happen?
If you decrease the temperature to 200 degrees Celsius, it will favor the exothermic reaction,
Yes, very good.
which is the forward reaction, and
Yes.
more products will be formed.
So more product will be formed. This means that the product yield increases as a result. Okay. So, but so we can, however, we cannot lower the temperature to very low. Why? Because this is also going to affect the rate of the reaction as well. So we have to select one such temperature, or a compromised temperature is kept for this whole reversible reaction, so that the rate of the forward reaction also increases and more product yield is achieved, and the rate of reaction is also not affected with too low temperatures. Okay. Yes, Zoya.
Miss, sometimes in the questions they give reversible reactions and they ask questions according to it, but normally, like in some questions, they're talking about the rate of reaction instead of the product yield. So they ask like, if is the product yield going to increase? Now, I don't really know if they're asking according to the equilibrium, or they're asking according to the rate of reaction. So how do I know?
If they're asking you the question in terms of particle collision theory, okay, this means that they want you to hit or to basically emphasize on the rate of reaction using or in terms of particle collision theory. Okay, this is one dimension in which the question will be asked. Otherwise, for instance, if they are basically asking you because they will mention in the context of the question what is happening. But for instance, if they are going to ask you something about the product yield or anything else, okay, so the temperature or any other factor will be involved. Okay. If they mention that, if they completely do not mention anything, okay, nothing is mentioned in the context of the question, they're simply saying that you are supposedly increasing the temperature to like 600 degrees Celsius, and they're telling you that the reaction, forward reaction is exo or backward reaction is endo and all. So in that case scenario, they will ask you both things. They will ask you whether the rate of reaction is there any impact on the rate of reaction, or is there any impact on the product yield. Okay. So you will mention both of the things in both ways. All right. You're going to mention that increasing the temperature increases the rate of reaction. Okay. Which means that the rate of this does not mean that the rate of forward reaction is only increased. Okay, are you getting my point? This does not mean that only the forward reaction is increased. This also means that the backward reaction is also increasing. No? Okay, and you're going to say only just say that the rate of reaction is increased as a result of increasing the temperature, but then you're going to mention that increasing the temperature to approximately 600 degrees Celsius would favor endothermic reaction, as a result, decreasing the product yield and increasing the concentration of the reactant as a result, or shifting the position of the equilibrium towards the left. In that case scenario, when no context is mentioned, then you have to emphasize on both the points, but in a very precise manner. And if they are simply asking you what happens in terms of particle collision theory, this means that they only want you to know or show the knowledge of rate of reaction, and to not even discuss the position of the equilibrium or shifting of the equilibrium. And if they are going to mention something about the product yield and they are telling you that any of the factor is changed, then this means that you have to mention and emphasize on the shifting of the equilibrium and how the shifting of the equilibrium is going to affect the product. Is this point clear?
Yes, yes.
Yes, Kayan.
Remember when you said if you decrease the temperature, you'll decrease the rate of reaction?
When the temperature is decreased, the rate of reaction decreases. Yes.
Can't you counter that by increasing the surface area or adding a catalyst?
Yeah, of course. Yes, if the rate of reaction is being decreased, and supposedly this particular reaction, this is the gaseous phase reaction. But if there is supposedly any other reaction whereby you can supposedly I have calcium carbonate, okay, and calcium carbonate reacts with hydrochloric acid, and I have decreased the temperature, okay. So decreasing the temperature or using cold dilute hydrochloric acid, which I would actually decrease the rate of reaction. But to counteract that thing, I can maybe I can change any other factor which is going to impact the rate of reaction directly by increasing the surface area of the metal carbonate I'm using in that reaction, by using a powdered form of the marble chips or limestone. Okay, so you can change the rest of the factors to directly impact or influence the rate of reaction thereby.
Thank you.
Yes. All right, moving on to the next one. So we've looked into how this compromised temperature for 450 degrees Celsius is used so that we allow a good amount of product yield to be achieved, and also a good rate of reaction is achieved. Okay. Then if you look into this is a gaseous phase reaction, which means that the reactants and the products, they're all in their gaseous physical state. Okay, if supposedly I increase the pressure, what is going to happen if I increase the pressure? Yes, I am.
Ma'am, by increasing the pressure, the equilibrium will shift towards that side where there are less number of moles. So by increasing the pressure, the product yield will be increasing
The product
because
yield
it will shift
increasing,
the
yes. So the
yes
shifting of the equilibrium lies towards
the right.
the right. Very good. And how do we know that where do we have less number of molecules or less moles of gaseous molecules?
By looking at the coefficients of
Coefficients.
the elements.
Very good.
Yeah.
So basically here on the left hand side, we can say we have 3 moles, a total of 3 moles, 2 plus 1 makes it 3. When no number is written here, it means it is 1. And on the right hand side, we only have 2 moles of sulfur trioxide. Okay. So increasing the pressure would favor the forward reaction to take place, as it is going to move towards that side which has fewer moles of gaseous product. However, decreasing the pressure, which means that more product yield will achieve. Okay, increasing the pressure means more product yield will achieve. However, if I decrease the pressure, it is going to shift towards that side of the equilibrium where there is more pressure. So more pressure lies towards the left, as there are greater number of gaseous molecules or gaseous moles on the left hand side. Okay. So again, higher pressures, you should know that any pressures which are greater than the compromised pressure. So compromised pressure of 2 atmospheres, it is set up for this particular reaction. Higher pressures is dangerous for safety purposes as well. And then it is also going to become the very expensive equipment is required for such reactions to proceed. And at a higher pressure is also kept to make this sulfur trioxide, to liquefy the sulfur trioxide. Okay, so all of the compromised temperatures, the compromised pressures, all of these things that are used, and vanadium 5 oxide is used as a catalyst here. These are used basically to balance the yield, to by looking into the cost of the whole industrial process, and also looking into the safety. Okay, so as a result, these compromised temperatures, the conditions which are kept, you can also say if they are moderate conditions which are basically used. Okay, any further questions by far? Yes, Zoya.
Miss, to liquefy the sulfur trioxide, we keep it at low pressures, right?
No, we use high pressures. We have to first pressurize the gas. Na? To pressurize the gas, we have to, when pressurizing it, we're going to basically allowing the gaseous molecules to come closer together. When they come closer together, then they are liquefied. And when they're liquefied, then they are kept in the storage tanks.
Miss, but for the Haber's process, you told us that we keep it at high pressures. No, sorry,
For-
at low pressures.
No, they're two different things that I'm explaining here. When you have to liquefy the gas, they have to be pressurized. Okay, once they're liquefied, then they're kept in such storage tanks which basically do not have very high pressures. Because if you increase the pressure to greater amount of pressures, then there's a greater possibility that it is going to decompose, which is why not very high pressures they are kept for the storage tanks. Okay, so there are two different things that you need to understand. One thing is that they are first liquefied, and for liquefying it, there is a need to compress it. To compress it, the pressures should be higher. Okay, once they're liquefied, then the storage tanks must not have greater pressures or very high pressures. So to minimize the possibility or the likelihood of the amount of the products which to be decomposed. Are we clear?
Yes, Miss.
Okay. So any further questions by far? Yes, Ryan.
What do you mean by decompose?
Decompose means breakdown of a particular substance.
Oh, okay.
Okay. All right. So I will be ending the session till here for now. Please mark your attendance in the chat box and then you may leave. Also, I've dropped a message in the group that I wouldn't be able to take or conduct classes from 10th of February. However, when we will inshallah resume classes on 24th of February, Monday, we will start from redox reactions. Okay. If anybody has any questions, or supposingly you are practicing questions or going through past papers or any other thing, you can directly contact to me on WhatsApp. No worries, I will be available there, and I will send you questions and PDF worksheets for these topics that we have covered so far. Also, I will be taking the quiz, and that quiz is going to include rate of reactions and chemical equilibria. The
Tomorrow,
quiz
right?
tomorrow.
Okay.
All right, take care. Allah Hafiz. Thank you. Bye-bye.
Hafiz.
Allah Hafiz.
Allah Hafiz.
Allah Hafiz.
Ma'am, can you send this recording to me on WhatsApp directly because I arrived a bit late? 15 minutes late.
Okay, no worries. I will also upload
Okay.
the link, Google Classroom. Were you able to access the rest of the links?
Yes, Alhamdulillah.
All right. Okay.
Jazakallah, ma'am. Thank you so much. Allah
No
Hafiz.
worries. Barakallah.